Everyone, so in this video we're going to look at anonymous functions. We're going to look at lambda expressions, and so just to kind of formally define what a lambda expression is basically a function that has no name, and we're going to see in what use cases or what are these typical examples where using a lambda expression is going to be useful. So let's do this. Let's go back and define our apply function. So again, just to recap, what I had in my one of my earlier videos on F# was we had this apply function, and the apply function was defined as a function that took in as a parameter some kind of a function. So let's call that function. It goes from an A to a B, and it took in as a second argument some value of type A, and then finally apply function would give back an output some value of type B. And I'm just going to define this function quickly in F# here. We're going to provide an implementation over here which is going to obey this functional type there. And so let's go and complete this, and so we'll call let apply that takes in a function f, and it gives back a value that happens to be f of x. And if I run this, I can see that this is the inference type for the function apply by F#. Now, furthermore, I'm going to now kind of one of the things we looked at in the last video was where we used we call some kind of a value that was computed by by calling the function apply, and then let's just for simplicity and just be consistent with what I had earlier, I had a function called let's say addition x of y equals to x plus y, and then I can say let some value equals to apply that takes in the addition function, and we'll partially apply this by passing in 1. So addition of 1 is basically a function that takes an integer and gives you back an integer, and now I'm going to pass in some other second argument to my function apply this x over here, and this x over here is going to be, let's say, 4. So value that's going to contain a value of 5 now. It's simply going to add 4 and 1 there. This is basically what the transformation does here. So this is the apply function applied on addition of 1 and 4 gives you a value of 5. Now, instead of going and creating this explicit function addition there, and again, this is kind of a silly example here, but we can see that in the silly example that the addition function is getting applied only in the context of this apply function. So why kind of do this, kind of have this overhead where we're creating this function explicitly, giving the name and so forth? One other way of doing this is simply by replacing this addition there, creating a function that is anonymous. So the keyword over here is fut. That is a function that takes in two parameters x and y, and simply basically adds x plus y there. Okay, so this is basically what the function addition is, and I'm going to partially apply this. By passing in let's say 1. Okay, so this, if I look at this piece that's been underlined there, let's just kind of put these brackets there just to make things a little bit more explicit. Okay, and so what I have here is this is my anonymous function. This anonymous function is partially applied with the value 1, meaning x is equal to 1. If x is equal to 1, so you can think of this function as some function. I don't want to give a name f there, but some function of two variables x and y. Okay, and let's just give it a name just to be consistent here, which is equal to x plus y. I'm going to partially apply it with x being 1. This gives you a function back of one variable, which is 1 plus y. So this entire piece in red, everything starting from the first parenthesis, in fact from this first parenthesis there, everything up to there, this entire piece in red is basically a function of one variable, which is 1 plus y. Okay, and now I'm calling apply, passing in the function 1 plus y, and I'm passing in the value 4. So apply is going to take in the function f, which is basically 1 plus y. It takes in the value x, which is equal to 4, and then I'm going to say f of x, where f refers to this function 1 plus y. So 1 plus y, and applying it with this value x, which happens to be 4, is going to result in 1 plus 4, that's equal to 5. So value in this case is going to be equal to 5. So if I run this and I see again nothing has changed here, value is still 5 there, and of course if I replace with some other value there, it says 8, this is going to give me back a value of 9. Okay, so this is just, I mean, it's really simple here. We're going to see function components, lambda expression a little bit more quite often when you start looking at map, fold, and reduce operators, and see how these are used in a very more from a very practical perspective. But this is just kind of a definition here, just kind of throw this at you to really know what are these lambda expressions. So let's just maybe just for kind of sake of clarity, let's just look at one more definition here. So if I create, let's say, some kind of a result that equals to let me do this. Let me come back to my apply function there, and let's now say result equals to, I'm going to change this from an apply to an apply to that takes in 2 variables. And now result is going to be simply, I'm going to call apply to, which is going to take in as a first parameter some kind of a function f, and this function f is basically a function, now in this case acting a function f of 2 variables. So let's just create a function of 2 variables x and y, that is x times y, and it's going to pass in my 2 parameters for x and y. So I mean that 2 parameters x and y is passing this is 10 and 30, and result is going to now simply be the multiplication of 10 and 30, so that should be 40. 10 and 30, that's 300, so so I get the result over here as containing the value 300. So again, just final recap, this f over here, this f over there refers to this function over there, and then I've got my x over here, this x over here refers to this value 10, and then finally I've got my value y, in this case that refers to 30, and I'm calling my function apply to. So let's just go slightly different color here. This is apply to, which is getting called right at that place here. Okay, that's the function name, and again you can see this is being calling in a prefix notation. So we're using the prefix notation here for calling the function apply to. That's my argument 1, that's a1, that's my second argument a2, and that's my third argument a3. Okay, and this over here is a1, that's a2, and this piece, this file over here is a3.